So let's bring up the project that the projects we did yesterday or last week. And let's take a look at what we did. That is really loud. Okay, and as we are going through review, combine it with like a little pop quiz. So we had we did the same thing twice, pretty much. So we had a project where we did everything with UIKit, and then we had a project where we did everything with SwiftUI. So we had UIKit, SwiftUI, and then we said one of them is declarative, and then the other one is imperative. Who remembers which one was which? So totally fine if you don't remember the names or which one was which. I'm just curious if anyone remembered. So one of them was declarative and one of them was imperative. Does anyone remember which one was which? Yeah? SwiftUI is declarative. Very good. Yeah, so this one's declarative. And I think like this. Okay, so what does that mean? In a declarative programming language, we just describe what we want to happen, and it kind of just magically happens. In an imperative programming language, we describe how we want something to happen. So if we want a view to hide, we tell the view, hey, hide. If we want something to move from here to here, we tell the view, hey, update your x coordinates or your y coordinates. In a declarative programming language, we have a property that says, hey, this is where it is, and then when we update this property, it just magically goes there. A very simplified explanation. So then let's so if the flickering gets too bad, if it's annoying, if it gets really annoying, we'll just pack up and find another room. So so let me know. So yeah, we have our UIKit demo. We started with that one. So let's bring that one up. So again, UIKit is imperative. So we describe what should happen. So we have a label right here. When we press the button, this function gets called, and we tell the label, hey, you have this, we're telling the label, hey, hide. We're telling the label to hide. And then, yeah, so maybe since we're here, a couple of other things. So we created our view visually here in Interface Builder. We connected our button by control dragging this button and then creating this action. So that's how we work with Interface Builder and our code here. And then for the label, for us to be able to affect the label, we control dragged our label and we created this outlet here. So we have actions and outlets. That's a very UIKit thing to encounter, or in this case, to be more specific here, an interface builder thing with which we can build UIKit UIs. All right, were there any questions here? This was probably the least new. So the language, the language, the pieces that we used from the language probably look pretty similar from C++ or Java, with a couple of weirdnesses that we'll unpack today. The way that we are programming looks nothing new here. So we're telling a label to update itself. So not too many surprises. So then we did the same thing again, this time in SwiftUI. And again, SwiftUI is a newer, is pretty new. It's maybe by now like 5 or 6 years old, which is very new. And yeah, so here we have our SwiftUI view. We have a canvas that can display our SwiftUI view, and it takes the code and represents it how it will look in the app. So this is very different from UIKit. In UIKit, we have the storyboard file, which is pretty much a big XML file. So you can think of this kind of like a website that lays out your components. So in the website, you have these XML components that are describing the actual Swift code that we have here. And then in our SwiftUI app, we have the canvas that is rendering the view components for a SwiftUI view. And so there's two modes. There's a live mode, and then there's a select mode. We're selecting a view component on our canvas. It updates. It'll highlight the view that we're talking about here. Same with the button. So if we're selecting it here, it highlights. If we're selecting it here, it'll highlight there. And we have two ways to modify our code here, our view code. We could write the code to modify something, or we can bring up our tab here on the right. So if we have the button selected, this should come up. It's not doing it right now. There we go. So we have modifiers. So we have the view modifiers. We'll talk a little bit more what it means for there to be a modifier on a view. It's not quite as straightforward as just a property that affects some change. But yeah, we'll do that later. So yeah, we have here our SwiftUI view, and how are we affecting the label? How are we hiding it? Again, we have a button. So this looks similar. So we have, which looks like something that gets executed when we're pressing the button. We didn't have to control drag. We didn't have to make any connections between our visual representation and our code by just writing the button code, or by just dragging the button component on here. Oops. We get this function that executes, and so here we are updating a property. Where is this property? It's not a property on the button. So there's not a button dot is hidden. Oh, sorry. There's not a property on the button. There's not a property on this label that we have here. On this in SwiftUI it's called text. In UIKit it's called label. So there's not a property on it that says is hidden, is visible. So how are we doing it in SwiftUI? Again, this is a declarative programming language. We have a property that is part of our entire screen here. And when we're pressing the button, we're updating the property that's on our view here. And just by updating it, our label will hide itself. So we have some code here that says if this property is true, we should show the label. If it's not true, then don't show this. So we're just describing what should be the outcome. We're not saying hide yourself, show yourself. We're just saying if this is true, then show this label. So I think to most of you this was a very strange thing. How would it do that? Very natural. So this was very new to me when I first worked with SwiftUI. But we'll unpack it. All of the weirdnesses here that we're seeing, a lot of it we will unpack. Any questions here? Cool. Okay, and then so the last thing we did was we talked about how views refresh themselves in SwiftUI. So we had the analogy of building a house. So in the more traditional way, how one would build a house, if there's a change, we would stop what we're doing and look at what we have and then make the modification. So the change that we made was maybe we add a window, so maybe we have all of our walls up already. So let's maybe make a little hole in this wall, let's add another window in. So that's how you're probably used to views updating. So you're not tearing the entire house down. You're looking at the wall that you want to build a window in. You're making the hole and you're putting it in. So SwiftUI has a more drastic way of updating itself. So we saw that when we're building this house, and one of the property updated. We stopped everything that we were doing. We were tearing the entire house down, and we were starting from scratch. So we just even if we're just updating the color of the house, we would stop what we're doing. We wouldn't continue. If we're maybe already building laying our roof tiles, we would scrap the entire house, start from scratch, and this time with this new color. So that was our analogy for how SwiftUI views update themselves, how they render, which sounds ridiculous. Like that sounds really, really ineffective, or not ineffective, inefficient. Does anyone remember what the benefit of this strange way of building a house, or in this case, building a view, updating a view? What was the benefit of this really drastic way of rendering our views? Yeah?
If something changes in between, it records the change and implements it, and we don't have to completely build a new thing, right?
So yeah, that's what we were doing. That was the old way of how we're used to doing it, right? So yeah, what is the, yeah?
It makes sure that the result is correct.
Correct, very good, yes. So what we saw with the little game that we played, I had looked at all of the requirements, and it took me not a lot of time to draw, but in that time, someone sneakily made some changes, and when I was finished drawing the house and I looked at the requirements again, it didn't match. So we have a multi-threaded environment in our phone. So we have the view thread constantly updates the view. We have background threads that might be refreshing things from the internet, that might be fetching something from a database. So we have multiple things going on at the same time. And if our view thread looks at something that maybe a background thread came up with, so maybe we're supposed to show a list of items, and we're like looking at the list of items, and now we're drawing that list of items. If it updates while we're not looking, then our view will not be the result of what we wanted to show there. So we can have a state where maybe not everything looks exactly how we want it to. So in SwiftUI, that is impossible. So the second something changes, we'll just scrap it, and we'll redraw everything from scratch. So that's how we're supposed to think about views updating themselves. And so our phone is a really fast computer. So compared to a desktop computer from 20 years ago, 15 years ago, these are really powerful computers. So it's negligent. The amount of work that we are redoing by scrapping everything that we had is negligent. And then, so we're supposed to think about it like this. What's actually happening behind the scenes, there's some really clever caching, and so behind the scenes, this is not actually what happens, but that's how we're supposed to think about it. Any other questions there? And then, so one way that this is enforced is our views are structs in SwiftUI. If we go back to UIKit, our view controllers in this case, but also our views. So our label here is a view. So our views are classes. Who remembers the difference between structs and classes? We briefly mentioned it. We're going to actually go into depth with that today. Who remembers the difference between structs and classes? Yeah? So in Swift, they can have methods. So we honed in on one, so this and the implementation of structs and classes might, so in Swift. So what is the difference between Swift structs and Swift classes that we talked about? Yes?
So structs cannot be changed?
Yes, they cannot be changed. Any other thoughts? Why can they not be changed? Does anyone remember what we compared them to? So there were other types that we encounter frequently that we compared them to. Yeah? Anyone? Say it again? So structs can have constants on them. So we gave some other examples. So if you're thinking of other types that we constantly interact with, what are some other types? So so integers, booleans, and doubles, for example. So those are all value types. So value types, you don't expect if you're passing them around. So if I pass the 7 integer into a function, I don't expect this function to change the innards of my 7 that I passed in there. Does that make sense? Like, I don't expect the actual object that I'm passing in there to change. If there's a change, maybe it gives me a new number back, or maybe the variable that holds the 7 is updated with a new instance. So value types, they're immutable. They're not really changeable. And if we were to mutate them, if we were to change them, we get a new instance. So we don't have an instance lying around that we're making changes to. If there's a change, we get a new instance. So that is how this mechanism in SwiftUI is enforced. So we have views that are structs. We can't actually change them themselves. So if we need a new version of this view, we'll just get a new one. All right, and don't worry. So we briefly mentioned this. We'll go into depth what this means, and we'll go over examples. Yeah.
Wait, so the key difference is that structs are immutable?
Structs are immutable. Yeah. Very good. Yeah.
And classes are.
They're mutable. How come they're mutable? Does anyone know? Does anyone remember what's the mechanism there?
For structs to be mutable.
For classes to be mutable, for us to be able to make changes to classes.
It was the add state thing?
Yes, so the behind the scenes with the add state, there is something classy hiding here. But yeah, since classes are reference types, so we have a pointer to memory, and then, we have the instance that lives there, and we can make changes to that instance that lives there. All right, very good. So I had thrown a lot of material at you guys, so we'll unpack a lot of that today. Yeah.
Sorry, so this
No, so questions are great.
So the state management, like directly related to our players and
State management, what do you mean by state management?
or like when it comes to state, how it's in Swift.
How it comes to state?
Yeah.
Yeah, so there is something reference typey hidden here. By the very end of the lecture today, we will know 80% of what's going on here. So right now, just have in the back of your mind, for a struct to be mutable, there has to be something there. Since a struct is immutable, but we want to affect something that is inside so we're changing a property, right? So we wouldn't be able to change a property on an immutable object. So there has to be something tricky here. And the trickiness, the mechanisms here involve a reference type. So we'll see this later. 80% of all the mystery of state will be revealed by the end of this lecture. Very good. So please, questions. If you have questions, they're amazing. So don't apologize. Any other questions? Cool. So we'll cover structs and classes in a second. Let me give you a quick overview of what we're going to do. So we are going to, let me hide this thing. There we go. So yeah, we had our review. So we're going to talk about, it's very windy. We're going to talk about something that's kind of that's been a little bit of an elephant in the room, especially in UIKit. So there's some really weird stuff in the syntax that we're seeing here. So to uncover that, we're going to talk about functions. Oh. And then we'll cover structs and classes. So that's our agenda for today. And then if we have a little bit of time, there's a little app that we can build with all of our knowledge, but we'll see how far we get. All right. Functions. let's take a look at what we have here. So there's some weird stuff hiding here. So I think we had mentioned what this at represents. So at IB. So IB stands for interface builder, and then we have an outlet, and then we have an at IB action. We had mentioned last week that it has to do with these special kind of connections from our view, our interface builder view to our code. So we can ignore this. So we kind of covered that. Let's take a look at this function here. So we have the func keyword, with the func keyword. We have a function name, we have a parameter name, and then we have a type, but we have this underscore. So that's a little weird. What's this underscore? Let's see if we can look at some other. Let's collect some weirdnesses about functions that we're finding. So we had one thing that we had here was so we have our parameter list, and then we had an underscore, and then a parameter name and a type name. So here we had underscore. So this was strange, and then we had a parameter name type. So this thing here is strange. Okay, first thing that we encountered that was maybe a little bit weird. All right, so let's look around a little bit more if we can see some other functions and some other weirdnesses. So last week we had only looked at this view controller file and the main file. So view controller, the view controller file is a .swift file. So if we go there, so view controller.swift. The main file here is a storyboard file. So that it's main. Oh, not new. Show and finder. So this one is a .storyboard file. So we had looked at those. What are the other things that we have here? So we have the app delegate. So we haven't talked about the app delegate yet. The app delegate is is the operating system's window to us and our way to communicate back to the operating system. So and this is in UIKit. So we have a slightly different mechanism in SwiftUI. So let's take a look at what we have here. So there's some additional weird things that we can take a look at here. I don't think. Yeah. So we have really long function names. So this is probably much longer than what you're used to. Yeah, let's show the entire beauty of these function names. So this is one function name, or I guess a function signature. So this probably looks slightly different from what you're used to in other languages. So let's take a look at this one first here. So how would I even name this function? So this function is called application did finish launching with options. So that's the name of this function. So in another language, maybe like Java, this would be the function's name. So that would be the function's name. And then part of the function's signature are the parameters and the parameter names and their type. So here we have, how many parameters do we have? Does anyone want to take a guess? I'm hearing 2. Everyone agreeing with that? So we have application, which is a parameter, and a type. So maybe we would have that. And then we have parameters launch options. So this is the parameter here that we have. And then this function returns something, which we denote with this arrow. What does this one return? A Boolean. Yeah, very good. So this would be very likely the function signature of this function in another language. So application did finish launching with options. And then we have an application, and then we have launch options. So those are the parameters and parameter names. Yeah, question?
What's the advantage of having it separated?
We'll see. We'll see in a second. Okay, so this is maybe weird. before we get into why this is so different, let me just give you a brief, some brief information about what this function does. So this is our first place, the first time in the runtime of our app where we can execute some code. So this gets called once when the operating system has launched us, and so the user clicked on the button to open the app. This function gets called just once, and then here we can execute some code, whatever we want to set up, and then if it returns true, the application will continue launching. So this is kind of you will likely interact with this function most when you're working with UIKit, because maybe your tracking will get initialized here. Maybe you have a database that gets initialized. So lots of things that might get initialized you would do in this function. All right, so now your question was, what's the benefit of things being strewn about here? So let's first let's experiment a little bit with this function here. So we don't really have a way to call this right now. So since it's in our app delegate, let's open up a little place where we can just play around with code. So if we go to File, New, Playground. So we've already done new projects. Now we're going to create a new playground. We get something that looks much simpler than what we have here. So we don't have an entire app harness. We have, here, let's make this much larger. We have some code. We have some lines on the left here, and we have a little play button, and then we have some space here that we'll see what it does in a second. So this is a playground. So if you're just playing around with some concepts, maybe we're creating an algorithm, or we're trying to play around with just a new thing that we don't know how it works yet. Playgrounds are really great because you can just, in isolation, interact with something. The other cool thing in playgrounds is you don't have to execute the entire thing. You can just click in the margins here, the little play button, and it'll execute until it reaches that point. So I just click there. We have the little spinner. So by default, Playground will use an iOS simulator in the background. This is why it takes a little bit longer than you might expect the first time that you're doing it. So it'll just boot up an instance for this to emulate the environment that we're in. Little trick here, if you're going to do stuff that's not UIKit related, so here it now finished executing, we have something in the margins. If you don't want to wait for this, it goes a little bit quicker if instead of importing UIKit, so we could import SwiftUI, for example, and then we can bring up the options and platform. We can switch to macOS. So it doesn't work with UIKit, it only works with SwiftUI, or you don't even have to have a UI environment. So Foundation has a lot of the functions and objects that we are interested in using. So if you either just import Foundation or SwiftUI, you can switch it to macOS, and then it'll go a little bit faster. So yeah, clicking in the margins will build your app, and will run whatever is here. And what's very nice is in the gutter here, whatever the state of an evaluated variable is, it'll just show it here. So it works also with things that you might not expect. So for example, if I have a color, here we have to then import SwiftUI. SwiftUI. So maybe we want a red color. And if I click in the margins, we will, it's taking a little bit here. Oh, so I guess for I think for UIKit it shows as a, for UIKit it should show as an actual red color. But yeah, so whatever is in those, whatever is in our variables we will, here we go. It shows us a little red dot and the makeup of that color. It shows us what's inside the variable. So very nice if you're trying to see how something works. You don't have to splatter something with print statements. Yeah?
How did you get to the playground again?
File, new, playground. And you can save this. So let's say you're experimenting with a new thing. You can save these playgrounds and then have a little list of little things that you were learning, which is very neat. All right, so playground. Let's play around with function signatures and answer this question: what's the benefit of not just doing this and maybe doing something else? All right, so let's come up with a something where that might make where it's a little bit easier, where we have types that we control. So let's come up with a function, and let's call this function divide. Okay, and we'll do it the same way that we're maybe used to creating functions in another language, and then we'll see the benefits of doing it the Swift way. So we can still mostly mimic how functions are written in other languages, but it's not the Swifty way. So if we have a divide function, we would have two parameters, maybe value 1 or value A. Let's say it's a double, and then value B, which is a double, and then maybe we have it return something, so it'll return a double. All right, so what I would expect, and then so let's just do the division here. Okay. And I guess we can return that. So how would I call this? So if, let's say we have a result, and then I'll call our divide function, and what I would want to be able to do right now, I want to pass in 4 and maybe 2. So that's how you would be used to it from other languages, I'm assuming. So we get a compile time error if we're trying to do it this way. So again, compile time errors are very nice. The compiler is helping us find a mistake that we made. Here we actually made a syntax error. So we forgot something. So we're missing argument labels. So I really wanted to read like this right now, though, because that's how you were used to it from maybe other languages. So how do we make this divide function behave like another language? So here we see the underscore. So if we add the underscore, so we saw that here, right here. We saw it here. So if we add the underscore, all of the errors went away. I can click here, execute, and we have the result too. So what does the underscore do? The underscore says there should be something here, but we don't want it. We want to ignore it. And this is true for the underscore. Wherever you see the underscore in place of, so it'll be in place of something. So you can, if something returns something you don't want it you don't want to interact with it, you can use the underscore to have it not matter. So underscore means there is something here. We choose to ignore it. So what happens? Let's remove the underscore again. And we're going to have the compiler now help us rectify how rectify our mistake here. So what is our syntax error that we have here? So we're missing argument labels. So if I click the red, there's a fix that the compiler is proposing for us, and it added what it called argument labels. So here we now, the way that we're calling this function, so this function signature looks like probably what you're used to in other languages. The way we would call this function signature in Swift would be divide value A, value B. So far, so far that maybe seems strange. Can you think of, we're going to unpack this a little bit more. Can you think of a benefit of of writing it like this versus this? Can anyone think of a benefit? We're not really showcasing this benefit yet, but so yeah, can anyone think of a benefit? Yeah.
Is it like we can track the specific values?
Yes, we can. You said we can track them and we can also describe them, right? So in a division, it's very important that we don't mix up the parameters, right? So they're both doubles. So if we're forgetting which way we had programmed this function, we wouldn't know. We wouldn't know. Yeah, but just by looking at this, it's maybe not 100% clear what it does. So let's make use of this. So I think I'm digging in my math words vocabulary here. I think that the thing that we're divising by is the divisor, right? And then the numerator and divisor. Is that right? So let's name them. So divisor and numerator. Okay, those are correct, right? I think, yeah. Okay, so now we have the numerator and the divisor. And so now the compiler will help us again. Here, let's comment this out. The compiler will help us. So now it says incorrect argument labels. And now we have divide, numerator, divisor. So if I did this, maybe it's not quite screaming at you that there's something terrible happening. But here, since we have the argument label for the second parameter that we have, so this should feel very cringy. Like this should be like chalk on your sorry, not chalk, fingernails on a chalkboard. So we're dividing by 0. So we now have a visual way of. We have a way of. Okay, well, this keeps going. Find a new room. So yeah, we have the parameter names. They're helping us now not make the mistake of passing in the wrong type, or not the wrong type, the wrong argument. Okay, so so I think maybe there's a start to answering why is there stuff in between. So the argument labels are part of the function signature, and it helps us figure out which parameter is which. So I would say if I had to translate what I did here exactly, so maybe it would be like this: divide numerator by divisor. So I think this would be a good translation of this into another language. So you could have something like this: divide numerator by divisor. Now it's a little bit more clear what you're doing here, but you would still have to go back and forth. Like you have to okay, so which one's the numerator? Okay, so the first parameter, second one is the second one. If you have 3 or 4 parameters, this gets more difficult to pass. So why is there stuff in between? One reason, so that we have these argument labels that help us figure out that we're making mistakes if we're passing in something wrong. Okay, so I find this reads a little bit nicer. Divide numerator by divisor. So I like this part a little bit better, but then I don't like this, just the list of arguments. So how could we make? And here I like that the parameter labels are very clear. So how can we combine the two? How could I take the niceties of this and the niceties of this and marry them together? So wouldn't it be nice if I could say divide numerator by maybe like this, by divisor? It's a little bit verbose, but so we'll work on this a little bit. So now this would be nice. This would be very nice to read. Divide numerator by divisor. That's a little bit more like an English sentence, and we would have the actual arguments sprinkled in there. We now have the incorrect argument label compile time error again. So our argument labels don't match what we're doing here, because we now are saying by divisor, which is not really a good variable name. So how could we fix this? We could change this argument to by divisor. We could change it here. Now, I feel like this reads very nicely. Divide numerator by divisor. But now we get into some trouble here. So return numerator by divisor. That reads really awful. So how could this be fixed? How could we still have the nice English-like sentence in a function and not have awful inner parameter names? So this is where inner and outer parameter names come into play. So we can just add another name. So here we have by divisor, and I can just say divisor, and the syntax error goes away. Oh, so this syntax error doesn't appear again, and now we have a syntax error here. So what have we done? We now have a function, divide. So if I were to read this function, the parts of the function that are part of the function signature, this function's name is divide numerator by divisor. That's the name of this function. And then on the inside, I still have very nice parameter names. I have my numerator and I have my my divisor. So this might look a little bit unfamiliar, strange looking to have these two names here, but you'll see this in Swift when it makes sense that you have if it reads a little bit better to have an outer parameter name and an inner parameter name, you have that option to do it. And we could make this maybe a little bit nicer to read. So I would argue maybe the nicest way to write this would be divide 4 by 0. Wouldn't this be a very nice way to write this function? Divide 4 by 0. That's like reads like a sentence. Reads like a sentence. There's a hint at what we're doing here. So we're dividing the 4 by something else. So we have a hint that we probably shouldn't put a 0 here. So we have the option of naming all of the parameters and give them even 2 names. But for this to work, so this one we can fix. So we have divide numerator by divisor. So this is now correct. And you guys should be able to fix the first parameter name. How do we fix that one? Underscore, very good. So, and this is where it all comes together. So in Swift, each parameter has an outer parameter name and an inner parameter name. And there's a couple of rules when we need to provide both, when we have to be specific that we don't want one of them named. So in this case, so the one of the rules is, so if you don't want an outer parameter name, you can use the underscore to omit it. And then we can make it read like an English sentence, divide 4 by 0. Underscore means we have an inner parameter name but no outer parameter name, and then we can provide 2 parameter names. If we don't want 2 parameter names, we don't have to. So if both the outer parameter name and the inner parameter name are the same, we don't have to specify both. So if you want to have it if you want to have it look like the function signature of like another language, you can do that. It might just read slightly awkward. So divide for divisor doesn't read quite as nicely. So I would say here, it's pretty nice to have that outer parameter name. Any questions here? Okay. To fully answer your question, why is there stuff in between? Because it helps us identify. So one, it helps us identify what we're passing in, and then it can also aid in reading it, having it be slightly nicer to read, having it imitate an English sentence. So let's go back and see how well Apple did with this one here. So, so this one was called application did finish launching with options. So that was the function name. If I were to call this is what it would. Yeah, let's comment this out so we don't confuse the compiler. Here we go. Okay, so this is how we would call it. So maybe this application is called UIKit demo. So I'm pretending that this is a parameter that we have somewhere, or a variable that we defined somewhere. So application UIKit demo did finish launching with options, and then the options we're passing in. So reads pretty nice. Awful to read when you're just reading the function signature here, but it does read quite nicely here. I would argue modern Apple code wouldn't do this anymore. So the reason why this is so long and so kind of clunky and awkward, so the app delegate, so a lot of this was written in Objective-C. And if you see Objective-C code, it kind of overdoes the really long functions, really verbose. Some of it doesn't read very nicely. So whenever something looks kind of awkward, feels a little clunky, it is likely a window into Objective-C. So the UI app delegate here is an NS protocol. Whenever you see NS, I'm not even sure what it stands for. So NS is a good indication that you're working with Objective-C. Well, you're interoperating with Objective-C. All right, question, yes?
Just out of curiosity, is there a reason why they made that trade-off? Because they assume people are using kits more? So
Which trade-off?
like having function signatures look horrendous.
Oh, I mean, so I think there's some automatic stuff happening of just translating. So if you look at Objective-C code in Objective-C, it kind of makes, for the rules of Objective-C, it kind of makes sense why it is like that. But then just the Swiftification of that often looks a little bit awkward. And then I guess there's also a little philosophy shift. So I think it used to be, so Objective-C that came out. Can you guys maybe close the door? Is that, or maybe they're walking by. I'll wait till they're gone. So yeah, Objective-C. If I'm getting my history correct, there was kind of it's not a really modern language, but it's so I think it's maybe by now like 40 years old maybe. It kind of came up at this time where we started having larger screens and like finer pixels, so you finally had a way to like display more stuff on the screen. And I think the philosophy there was, and I mean, don't quite quote me on this, but I think that's kind of what happened here. Is like, oh, we have all this space, so let's the philosophy was, let's make this language feel like English. So that was, if I'm getting my history right, one of the goals for Objective-C. Anyways, any other questions here? So yeah, we have kind of all the rules, the like enforced rules and the mechanics we now know. So we have two parameter names, an outer one and an inner one. We don't need both of them if they would be the same. Actually, the compiler would complain if we have the outer parameter name and the inner parameter name the same. So we get a warning. So this is not a compile time error. It just says extraneous duplicate parameter name. So it already has an argument label. So it's saying, hey, you don't need both of these. So if the outer and inner parameter name are the same, you don't need two. If you have an outer parameter name that you would like to specify, you may, and then you have these two parameter names. If your function should have no parameter name, you can use the underscore. And so these are the next things are kind of guidelines. They're not rules, so the compiler won't tell you to not do it. These are just kind of the Swift languagey feel. It should feel like Swift rules, and those are you're not. So this you're not supposed to do. You're not supposed to have more than one unnamed, more than one parameter without parameter names, without outer parameter names. So you're not supposed to have more than one. If you have an unnamed parameter name, it should be clear from the context. So let's say maybe we have a function square. I feel like this is pretty clear from the context of what's going on here. We're going to square this number. So this would be less good, I think. Square value. I think this reads less nicely. So I would say here it is advisable to not have a parameter name. So yeah, that's one of the guidelines. And what were other ones? Yeah, I think that's you're not supposed to have multiple unnamed ones. I think that was kind of the only one. All right, any questions here? Cool. Okay, so it's been an hour. I'll give you guys a 10-minute break, and then when we come back, we'll start tackling structs, classes. What are they? Why do we need both? Why is UIKit using classes? SwiftUI using structs? We'll unpack all of that. So let's come back at 8:08.